Okay. So, good morning to all the participants and all the guests present here this day. I, Dr. Piyush Charan, Associate Professor, Department of Electronics and Communication Engineering, take the privilege of welcoming all the participants to the international webinar on embedded ML on edge devices running in stealth mode. It is indeed a pleasure to be a part of this event as an organizer for the event. I welcome Professor Shruti Vashisht, Dean of Engineering of Manav Rachna University, Faridabad, and Professor Charu Pathak, the Head of Department of Electronics and Communication Engineering, Manav Rachna University, to be our special guests for gracing the event with their auspicious presence. Professor Vashisht has a vast academic experience and have published research papers in journal of repute in the field of wireless communications and wireless sensor networks. Due to her vast experience, commitment, and dedicated work style, she is holding additional charge as the Dean of Academics at Manav Rachna University. She is a decorated academician. On the other hand, we have Professor Charu Pathak, who has been an extremely motivating and generous leader to all the staff members and students. Professor Pathak has more than 21 years of academic experience, and her research interest is in the area of signal processing, image processing, and etc. With these words, I would like to invite Professor Vashish to address the audience and officially inaugurate the departmental YouTube channel. Ma'am?
I once again welcome Rohit sir and good morning to all the students and faculty members who have joined us today. And I'm sure that this session would be imparting great knowledge about ML, because see, the concept is that for from electronics and communication domain, we always think that this AI and ML is always related to the computers domain and not from the electronic side. But today, I'm sure with the help of the session that we'll be having here today, we will get to know how we are going to embed, what kind of technologies we can use so that we are able to club in ML technologies in your embedded systems and as electronics as a whole. Now, about the session, Dr. Piyush will give you the details. I'll just share a brief about Manav Rachna University, what Manav Rachna University is all about. So basically, Manav Rachna Educational Institutions has got three higher educational institutions, that Manav Rachna International Institute of Research and Studies, we have Manav Rachna University, then we have Manav Rachna Dental College, and number of schools under its umbrella. And Manav Rachna University is a leading state private university, that's a NAC-A accredited institution, and among top two emerging engineering institutions of India, which has been ranked number one engineering institution in India for research capability and placements. We do have our strong placement cell, which always supports students for placements in top emerging industries. So that support is being provided by our CRC cell. And Manav Rachna is also ranked as best knowledge creation and innovation universities. So we do believe that as the technology is changing, it is very important to bridge the gap between academia and industry. And we do have knowledge partners. In electronics department, we have knowledge partners as TrueChip, because we know that VLSI area is coming up like anything. So because of the help and support from the knowledge partners, the syllabus and schemes for the students are developed gradually, and therefore they are there to support us in guiding how to go about the syllabus, how to go about the scheme, so that we are not lagging behind what the industry needs. Because initially what the concept was that the department used to work solo. Yeah, each and every individual department works in solo and design our own curriculum and syllabus, and we do not know what's going around in the industry. But with the help of support of industry, we do know that what is the requirement of the industry, so that once the student gets placed, the industry person need not invest more time in training that person. So that's the philosophy behind having these knowledge partners with us. So with these words, I would like Dr. Piyush to carry on, and I hope we'll have a wonderful session, Dr. Rohit. Thank you.
Thank you, ma'am. Thank you, ma'am, for your words of wisdom. Now, I would like to invite Professor Charu to address the audience.
Yeah, good morning, everyone. Welcome to the session, and thanks, Dr. Piyush, for organizing this, taking wonderful initiative, Rohit, to be a part of our initiatives regarding education, with our giving exposure to our students. And Professor Shruti has already highlighted the main points of the university. Other than that, I will just like to take just highlight few points regarding our education system at our department. The important thing that we have just initiated in last 1 or 2 years is that we have moved from the traditional teaching pedagogy to the project based learning system, and which has been extremely useful in imparting students knowledge which is actually a combination of number of streams like mechanical, computer science, and electronics, because future lies actually in combining all the three together as we are advancing towards automation, AI, and everything. So a student needs to have uh, knowledge of all the streams together. And then other than that, the university and the department have been very much supportive in promoting students to have their startups file patents and promoting research. Other than curricular activities, we have been promoting students to participate in extracurricular activities like sports and uh, fests at other institutes. And the students have been taking up, they have been winning medals at other universities at international levels, Microsoft Imagine Cup, and various other internationally hackathon and internationally recognized competitions. So I think that is we are also open to more we as Professor Shruti already mentioned, that we have collaborations with industry, and we are open to more academic and industry collaborations which can add bring our students more closer to industry and the upcoming technologies. So I think that's all from my side. Thank you so much.
Thank you, Charu ma'am. Moving ahead, as we have gathered here in this live streaming, we all take pride to inaugurate the official YouTube channel of the Department of Electronics and Communication Engineering, Manav Rachna University, Faridabad. With our very first guest speaker, he is none other than Professor Rohit Sharma. Professor Sharma is working as an adjunct professor in the California Science and Technology University, Milpitas, California. Professor Sharma has been working in the field of embedded AI and integrated machine learning to make devices smart and have created many projects. He is the founder of the AI Tech Systems, Milpitas, California. He has authored a book called Introduction to TinyML, which encapsulates all the technicalities related to embedded ML, and have documented various projects for smart home, smart farming, smart industry, smart science, smart health, smart computer vision for intrusion detection, and etc. Professor Sharma, I would like to start off today's discussion by asking you, how are you today?
Oh, thank you, Dr. Piyush. And before that, thank you, Dr. Shruti and Dr. Charu, for inviting me to this forum. It's my pleasure. And thank you, Dr. Piyush, for giving me such nice introduction and kind words. I'm wonderful. It's
Pleasure is all mine.
7:40 p.m. here in Milpitas,
Yeah.
and I'm glad to say hi to everybody who's joining online.
Okay. Hi, sir.
So,
Uh,
shall we get started?
can you give a brief of your journey to California and how machine learning intrigued you to build these smart projects? And can you tell me something about your book so that our audience can relate to?
Yeah, sure. So this is the book that we have recently written, thanks to AI technology and systems, and my friends and colleagues and everybody working in the company to collaborate and provide the material for that. So we would be talking about Introduction to TinyML and the projects listed in this book. There are over 140 applications that Dr. Piyush will give you the link to. Today,
Yeah.
this book is available for free for the next 12 to 24 hours in the Indian zone. And Dr. Piyush would give you the link to download the book. And if you have time, I would love you to sort of skim through the book while we are going through this, these applications and such, and ask questions. The main motivation behind this talk is essentially to inculcate your interest into embedded machine learning and so-called tiny machine learning. We often in the industry call it TinyML, and it's a part of embedded machine learning. Um, there are subtle differences, but I'll be using TinyML and embedded machine learning as synonymous during the course of this conversation. As for my personal journey, I graduated from IIT Delhi in '98, and I came to California in '99. Worked for several startups. Most of them were acquired or went public. So I've been lucky to work with extremely talented and hardworking folks, and some of their smartness has rubbed on me, and I'm we are doing a wonderful job in the area of machine learning. How we picked up the story behind that is, in my last company we started machine intelligence in design automation, and we ended up writing part of the stack, the entire software stack that has come to known as similar to PyTorch or TensorFlow. In 2013-14, there was no TensorFlow or PyTorch, so we ended up writing something similar for our work. And in 2017, when the company was offered a term sheet, the AI was still up and coming, and we were looking as to where this can be applied. And the one area that was not touched by 2018 was embedded systems, because machine learning inherently in the media is talked about as something that requires GPUs, TPUs, and very high-end, high-performance computing. And so that's the idea. I came out of my parent company, and we started experimenting as to how many applications we can bring onto smaller and tiny systems like the one you see in my hand. It's a Silicon Labs board which runs on a coin cell battery and has a microphone and other sensors on it. So what we're going to talk about essentially in this forum is how you can bring machine learning and deep learning, more so deep learning, onto these tiny boards like this, or Raspberry Pi Pico Zero, or Arduino. Some of these are very popular and very inexpensive, so to say. What they have built in is few sensors that are attached to them on the board itself. And the kind of compute you would see in the board is very limited. And we'll go on and differentiate the boards and the hardware we have versus what is used in mainstream, and compare that with cell phones and GPUs and desktops and such. Okay, so that was my journey. Back to the point. We would like to start. Keep this book in mind. Please do download it. And if you can, start reading with me either on your cell phone or a cloud reader or wherever Kindle readers are available.
Okay. So we are good to go, sir.
Yes.
So now the stage is all yours. So you can share your screen.
All right. Everybody can see my screen.
Yes, yes.
All right, great. So we're going to talk about Introduction to TinyML, the book that I hold in my hand, and the idea behind this conversation is to disseminate the information about this up and coming embedded machine learning and TinyML field, the technology and applications and algorithms and platforms and such. We're going to talk and touch every part of that, and we'll keep it at a very high level. The entire idea of this conversation is to improve and inculcate your curiosity so that you can ask questions, whether you can see your career improving, or whether you can see yourself joining this 1 or 2 years after you graduate, or do your master's or PhD, or whenever you would want to come to join in the industry. Would you like to join as an embedded ML or TinyML engineer? So with that, keep your questions coming. Here is the agenda. We're going to focus our attention to applications and use cases. I'm going to present 4 use cases. American Sign Language, which is essentially your hand movements and gestures. And how can we help a mute person who is not able to speak to hold the conversation. So when in American Sign Language or even in Indian Sign Language, this is hi, how are you? They cannot speak. So these signs are essentially used to communicate between, two people. One or more of them is mute. Now, with this application, we can use some movement sensors to convert these gestures into spoken language. So you can have the speaker at the back of your wrist, and when you're making the movements, the smart applications that is running on one of these tiny boards will translate those movements, and the speaker will say those words, and we can communicate with mute population, which is almost 70 million in the world. That's the first application. The second is Wakeword detection, which is, we all know about smart speakers like Hey Google, Hey Alexa, and such. How do you create a wake word with your name? So, for example, if I would like to create a wake word with Hey Rohit, or say Dr. Piyush, Hey Dr. Piyush, and the sensor wakes up and starts listening to the rest of the commands. And third is person detection, which is like, how do you detect if what you see in the frame is a person or an animal, or it's just a scenery like a building or tree or something. So whether there is a person in the frame or not is that application would tell you. The fourth one is predictive maintenance. Anything that vibrates, like machines, pumps, motors, they have certain vibration characteristics, like harmonic analysis, which is essentially a fancy word for frequency analysis. Machine learning can spot the patterns as to what are those healthy vibrations versus unhealthy vibrations, and it can tell you a lot more about the machines just by sensing those vibrations. We will talk about those 4 TinyML applications, which actually are these 4 chapters presented in this book. And they have no code approach, where we have provided the applications. You don't have to write a single line of code. Just come up with the boards that are listed in those applications and start touching and clicking the buttons on the TinyML.studio platform, and at the end of it will give you the entire binary that can run on that board. And low code, if you want to come up with your own data set and such, and would like to modify parts of the deep learning model, then we have a low code platform that you can use to create the entire flow. And so we'll talk about TinyML frameworks, tools, and techniques, and in the end we'll touch a bit on algorithms and optimizations. And like I said, I'm open to questions. And Dr. Piyush, if you can please help me, as in when you see questions every 20 to 25 minutes, I would take a break and address those questions.
Yeah, sure, sir.
Thank you. So with that, let's move on. This is talking about how did we, come up to the industrial revolutions. Starting with 1784, where there was no industry. Essentially, steam power just showed up, and that steam power revolutionized quite a few things, including railroad. Before that, the industry was intensely local. If you produced at one place, it has to be consumed at the same place. There was no transportation per se for longer distances. Steam power changed that, and that was called Industry 1.0. And then came the era of Industry 2.0, essentially mass production of assembly lines and electric energy. And machine learning is kind of touted as electrical energy, and in the sense that by itself it's not much of a technology, because it doesn't do much by identifying a person or looking at vibrations. The applications thereof are very powerful, and I'll give you examples similar to electrical energy. For example, there is not much you can do by moving an electron from one place to another, right? And that's all there is in the current, right? And in electric power. But when you provide electric power to the entire planet, the applications, starting from electric bulb to the hundreds of appliances that are very popular in the households and the buildings today, that you cannot imagine your life without, essentially life, the way you live your life changes quietly because of those innovations. And electrical energy in late 1800s was one of those. And then came semiconductor era. With the semiconductor in 1970s, you started seeing these little tiny chips that started bringing automation to the industry, and smart bells and little tiny robots that are building cars today. They've been building it for almost 30 to 35 years, and the automation continues to make us efficient. And that was Industry 3.0. And the 4.0 essentially is IoT, TinyML, and cyber physical systems, where the senses that humans have, like we have our eyes that we see with, and there are cameras like the one you see in my hand. It's a tiny RDU cam, and it's a very tiny chip. And you can capture reasonably sized video on this with limited latency, and can run some of the applications. And the deep learning part, which is AI vision, today, actually not today, going back 8 years, has outperformed human vision. So the machine learning or deep learning does a better job of identifying an object as that object versus a human would do. So we are verifiably inferior when it comes to our senses, especially our audio and vision senses. So that is the sense of industrial revolutions, and as to where we are in 2022. And how this went about in creating some of these infrastructures, essentially water, steam, mechanical production, electricity and mass production, and robotics and such. Internet of Things essentially combines a lot of these applications industries into smaller verticals that creates these efficiencies on automation in each areas of our lives and factories and jobs and daily routines. And one thing that each one of these little tiny boards have in common is they are connected to internet. And what we're going to talk about today is, the IoT has been there for almost 8 to 10 years, and there are several applications. The next wave is coming where you don't have to connect. The connectivity is optional. What that means is you can run the entire AI application on this board, which you are carrying around in your pocket, running on a AA battery or a coin cell battery, and it's not even connected to internet. You can go in the space, you can go in the shipping, mining, smart farming. There are a lot of industries where the access to electricity or internet can be luxury. So we are sort of touching and completing that reach of these smart AIoT things to 100%. Now, there is one thing I would like to clarify here. IoT versus AIoT, there is a minor difference. IoT is Internet of Things, and when I say AIoT is artificial intelligent of things, meaning it's not internet, it's artificial intelligence of things. Internet in AIoT is optional. You can connect, you can add internet or GPRS module on top, and that is optional. So IoT and AIoT seem similar, they are not. And you might have heard or you will hear about this taxonomy, where it goes like AI is a large field, machine learning is a part of it, and deep learning is a part of machine learning, and neural networks is even a smaller part. Now, where does TinyML fit? TinyML essentially is the intersection of machine learning, deep learning, and neural networks, somewhere here. And the differentiation of that is, when we are looking at the small power, small boards that may or may not be connected to internet, is essentially your TinyML. And some of the taxonomies that I'm going to talk in this forum, in this talk, is network. When I say network, it could be cloud, it could be edge. Edge devices are something you carry around on a daily basis, like your cell phone, which is an edge device because that device is not sending the data further. It's basically the data comes, gets consumed on your device, and goes back. So that's an edge of the network, if you would. Cloud is essentially server where things get processed. ML, when I say model, I'm talking about a model in the context of machine learning. Training meaning we are training a model. Inference meaning the model is trained and we are using that model. And hardware, IoT or MCU. IoT is essentially your Internet of Things. MCU is microcontrollers. And the benefit of TinyML that I'm going to talk about in the next few slides is low power, low latency, and security. And so this is the hardware that we're talking about. On the x-axis, you see increasing power and cost, and on the y-axis, it's essentially a compute measurement, which is flops, called floating point operations per second. As they go up, power and cost typically goes up, and the microcontrollers are typically from few milliwatts, like 1 milliwatt, to about 1 watt, and that's where your TinyML applications come in. And if it's taking more than 1 watt, like your Raspberry Pi, that's not TinyML. Raspberry Pi is about 5 watts depending on the application. And cell phone is definitely not TinyML. A cell phone is a powerhouse for TinyML kind of application. Raspberry Pi is again another powerhouse, and I'll give you an example as to differentiating their compute power. And then you have applications like smart car, which is hundreds of watts of power in that one vehicle, which has huge processing power. As good as remote server, if not more. Any questions so far, Dr. Piyush?
No, sir, not yet.
Okay, great. So let's keep going. For what do we do? So how do we develop? This book, fourth chapter would talk about the steps for the TinyML development. Essentially, on the second chapter, we talk about understanding TinyML, need, benefits, list of TinyML verticals, and such. And so what do we do when we talk about developing a TinyML application? Essentially, these words, they have sensors. What sensor means in this context is your camera has image sensor, your audio, microphone is audio sensor, gyroscope, accelerometer, these are movement sensors, and you might have magnetometer, which is your magnetic sensor, and there are other kind of sensor which can sense flow, your location, and such, right? And there are over 1,000 sensors for different kinds. But the whole idea of the sensor is that you connect that sensor to a board, and sensor is taking the data into some other form and converting into a digital form. So, for example, image, right? All these sceneries that we see are converted into pixels. Pixel is nothing but an 8-bit or 16-bit representation of a very tiny dot that creates the whole picture. And same thing with your microphone. Microphone senses a sound waveform. The speaker will convert that sound to a power waveform that you can analyze in terms of the frequency band and its characteristics, and spot the variation and spot the pattern into identifying whether it's your voice, my voice, dog barking, glass shattering, or something else. So gather data is the first step. Then you design the network. Network meaning neural network. And then you train the model. So the model is trained, and the model says my accuracy is 90%, 95%, 98%. And the more the complexity of the data that comes from the sensor requires high-end, high compute models that needs to be trained with high accuracy depending on the criticality of the application. And once the model is trained, then you validate. Validate as in you have collected the data from, let's say, for camera from January through March, and you would like to validate that on the pictures that were captured in July, because the model now has never seen the pictures that are captured in July timeframe. Why do I bring up these months into this picture? Is because essentially the model sees the data that it has never seen before during training. So you're validating, does it do a similar um, does it bring out the similar accuracy on the data that it has not seen before? So that's a model validation, and then you compile the model. Compilation is one differentiation, which is very specific to embedded systems and TinyML boards. These boards cannot have operating system, meaning you have to compile the model. They can't run Python. Python is where the whole industry is tuned to training the model. It's very easy to train a model using Python and the Python related frameworks like TensorFlow and PyTorch and MX and Cafe, and there are a lot more. So the language that is used here is Python, but then because these boards are so tiny that the memory and the flash, which is the hard disk, is less than 1 MB. Now compare that to your cell phone, which is about 64 gigabytes of hard disk. 1 MB versus 64 gigabytes is about 10 to the power 4 to 10 to the power 5 difference in just storage. So it's a huge order, 4 to 5 orders of magnitude difference between the board that we are talking here and your cell phone, which is probably a basic device for you. Wasn't so back in 1970s or 80s. Just so you know, give you another example, the cell phone that you have in your pocket today was used to send a man to the moon. The kind of compute you carry in your pocket today, that compute wasn't available back in 70s, 60s to 70s. And the scientists, they used very large computers, which if you compare, the compute power is similar to what you carry around in your pocket. So we've come a long way in terms of compute, but still we would like to bring the TinyML devices onto the basic compute, essentially the microcontrollers and boards of 1980s. So what is TinyML, right? Many things, including low power machine learning apps. They're running on embedded systems, typically without operating system. You can run them with, like if you have slightly more powerful embedded systems, like you have 4 to 8 gigabytes, you can run it on RTOS and some other lower compute consuming operating systems like FreeRTOS, which is real-time operating systems and such. And like I said, you don't have to connect to internet or the cloud. So cloud connectivity and internet connectivity is optional. It makes the compute affordable because you have the entire board in your hand with the application running on it is within $10 to $20, sometimes $50. And your cell phone typically state of the art, like for example Pixel 7 is about $700 today. So 10 to 15 times lower cost. And of course it fosters privacy because your data is not leaving anywhere, and it has low latency because there may or may not be a network, so you don't have to rely on a remote server to get connected and provide the throughput and the latency that the application requires. So why TinyML, right? I'll give you one example. I have several, but because of the interest of time, let's talk about image sensors, right? We are in 2022, and number of image sensors that were produced in 2022 is about 10 billion in 1 year. And given that one image sensor average life is about 3 years, in the world there are approximately 25 billion image sensors. Now, if you compare that to world population, which is about 8 billion today, on an average, you can quickly calculate that on an average, one person, including a baby, is carrying about 3 image sensors. And so those 3 image sensors, the kind of data those sensors are producing is of the order of 10 to the power 20 bytes per second. So one followed by 20 zeros. So that's called 100 exabytes per second. Now, why that bandwidth is interesting is because if you look at the entire internet bandwidth today, the entire bandwidth of all countries combined, all the digital data that's floating around the earth is about 45 to 80 gigabytes per second, which is of the order of 10 to power 10 bytes per second or 10 to power 11. And so we are 10 to power 9 to 10 to power 10 bytes per second away just to support these image sensors. And that would take another 10 to 20 years for us to create the kind of networks that are required to support all these sensors and their data being stored in the remote server. So the problem we have is we don't have enough bandwidth. Even if you throw the entire internet bandwidth on these sensors, you're not doing enough. You won't do good next year, 5 years from now, and maybe 10 years from now. So there has to be other solutions, and one of the solution is that you consume the data that is produced on these image sensors on the board itself. You don't communicate, you don't transport that data back to the remote server. And that is why TinyML starts to shine in areas where you don't have connectivity, or you need to process that um, image sensors data frame by frame on a tiny sensor where you don't require connectivity. We are actually forced to use some of these applications without connectivity. So this is one, and I can go on and talk about other reasons why TinyML is shining and expected to outshine some of the prevalent technologies like cloud and such. Let's talk about hardware, right? I give you an example. So here is the slide which talks about GPU servers. And I'm going to talk about just the RAM, one parameter, which is RAM. Typically have 64 gigabyte or higher on a GPU. Compare that to your CPU, which is a mobile or a laptop, 4 GB to 8 GB. And these tiny machines, like Pico Zero or Arduino Nano or some of these other boards, they have 256K. So you're dropping 64 to 4, which is about 16 times, 15 times one order. And this is going from gigabyte to kilobyte, 6 order right then and there. So the drop of the storage, the compute power in terms of frequency of the processors and GPUs, in terms of measure in terms of flops, is incredible. There is about 10 to power 10 order, like 10 orders of differences between the GPUs that do some of this machine learning and what we are attempting to do on these tiny machines, and that's why it's challenging. So now let's talk about AI, the use cases, right? So on, if you look at the third chapter on the introduction to TinyML book, third chapter is devoted to AI speak, essentially, which talks about how do you convert the gestures to spoken language. So, for example, this animation is saying "I love you," and that's the gesture that if you have a sensor in your fingertips, let's say accelerometer or gyroscope embedded inside or on your fingertips, and this gesture is made, the machine learning will spot that pattern and quickly convert that into spoken language. And that's the idea. The idea is to give voice to the 70 million mute population, on the planet. So how do we go about? By the way, you might want to note this URL, which is essentially you can go on it, sign up for a free account, and look at the entire sensor app.
So we have a first question.
Sure.
Okay, so this is on your screen.
Mm-hmm. I can't
It's
see my
from-
screen. Can you?
Okay. So this is from some Lavanya Garg, and she's asking, Sir, isn't it difficult with TinyML to determine when data paths and pre-processing steps can vary significantly between devices?
Um, so data paths meaning sensors. Yeah, so you can connect different sensors, right? And that's the beauty of it. Like you can connect camera or a microphone. So that's one part. Other variation of data is essentially how do you process this data to create the application. It is true that for every sensor, you will have to have a sense as to what is the best methodology to use that kind of data that's coming from these sensors. For example, your cameras, they need to be converted to some kind of a matrix, which in data sciencey terms called NCHW, which is a sort of four-dimensional tensor. For an audio waveform, it needs to be analyzed into some kind of a frequency transform. So it depends on the application. So there are these two. I would call them difficulty. These are solved sciences. It's just a skill that you have to pick up as a data scientist or a tiny machine learning engineer, and add to your computer science or electronics knowledge, like Dr. Charu said in the beginning, that it's not just electronics, electrical, or computer science, mechanicals, and the other engineering. They're coming together to create one application, and that's the beauty of engineering, right? An engineer does not care where the solution comes from, whether it's coming from mathematics or physics or some other basic sciences, fundamental sciences. He's focused into creating something that makes the world better, right? So in these 3-4 branches in TinyML are fused to give you a sense of a smart application. So correct, it is somewhat difficult, but it's a solved science, and it's just a skill that you have to pick up, right?
Okay, sir, thank you. So we'll wait. You can continue with your slides, and as soon as we have our next question, we'll again ask you though.
It'll be pleasure. So
Thank
yeah,
you.
please keep your questions coming. So this essentially this is the flow. I mean, at a very high level, you have the accelerometer and gyroscope data, which is fed to a neural network, and neural network will predict top 5 words, that what is the possibility of this sound waveform matching closer to this word, and we pick the top one and then the next word predictor. So for example, when you type in something in the Google is always predicting ahead as to what you're going to type, right? And it's similar to that. Algorithm is similar to that. And then once it is sort of confirmed, then we convert the entire sentence to a speech and say it. So it's as simple as that. Your network is shown on the lower part of the screen, which is essentially few operators. You can make it more complex. This works for 5 words, but if your word goes to become more complex, like 5,000, typically 500 to 2,000 is a good starting vocab for anybody. I mean, we don't speak more than 5 to 8,000 words in our daily spoken language, so those words are limited, and the entire lexicon, the dictionary, has about 500,000 words. So the science for computing and converting these audio waveforms to sentences is somewhat limited. It's not like space where you have the space is expanding forever kind of a problem. It's a limited problem set that we are dealing with here. And in terms of flow in the real time compute, is you sample the audio, you create the spectrogram, which is essentially a fancy word for frequency analysis. You convert that into ML model, and then if the ML model says yes, this is my Wakeword, like hey Google or hey Alexa or hey Rohit or Dr. Piyush, it wakes up and starts listening to the next command or sound. So that's the Wakeword detection, and again, it's the same thing. Another flow of a bunch of algorithms, STFT, And then you have convolutions and mathematics in linear algebra, matrix multiplication, convolution, transpose, and such. And yeah, so these are sort of done in series, one after the other, and you have at the end of this neural network a probability that somebody said that Wakeword or not. That's the second one, and there is an entire chapter devoted to that, which is chapter 4, and it has audio backward detection starting at page 38. So you would see, next 15 to 20 pages just for this application, and it has two approaches to it. One is no-code approach, the other one is low-code approach, and you pick your battles as to where you want to go to create that. I would encourage. So let me see if I can show you guys. So if you have time, I want you to sign up for this platform, and let me show you right now how that thing works. So I'm already signed in. If you go on to the playground and then click on this, which is your audio Wakeword detection. So if you click on that, you will see these two screens, right? And right now they won't work for me because my microphone is used by the webinar that I'm currently holding. But what you have to do is to sort of record your sound, which is audio hotword, in the background, and then click train. And on the next screen you will see a test screen, which is essentially your audio testing. So when you're done creating the model, let me go back. So here you will say, for example, wow, 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 and then you will say it like few times, 50 to 100 times. And here on this screen you will say anything other than wow. And so wow is our keyword. And when you are done creating that model, when you hit training takes about a minute or two, then you go on the test screen. And in this, let's see if it works. I'm not sure, but let's take our chances. Wow. Today is Thanksgiving. Wow. And let's test this on the model that we already trained and see how that comes around, right? So while this is working its way to the test, let's move on to the person detection. So this is vision. So far we have covered two applications. One is your sign language detection. The second is audio Wakeword detection. This one is we are moving to vision, which is sort of capturing the camera and identifying what is in the frame. So okay, so we are here. So let's see. I'm going to play the audio waveform, and these green bars essentially they represent whether the keyword wow was detected or not. So the keyword was detected from here to here in the waveform, and then in the end. So let me play the entire waveform so that you can see. Wow. Today is Thanksgiving. Wow. So it did detect. Right now, this is no code approach to creating a smart speaker like Hey Google or Wow or Hey Dr. Piyush or whatever, right? When you are done with this kind of experimentation, you pick your board and such. For example, you can use Raspberry Pi or Arduino Nano, and then you say, okay, I'm going to download the library or the entire binary for that. And when you do that, you can compile, and then it will give you the entire binary on demand within few seconds. Right now it's compiling as we speak, and in few seconds we will have the entire binary. So this is our binary that you can open and look. And I think I did for a .a, which you have to do create the entire application on top of this. So there's a README that you can read how to use it and such. So it's as easy as that. Even if you did not know anything about the spectrogram and this and that, all you have to do is to record a bunch of your hot words and download the application and start running on Raspberry Pi or some of these boards. So please do sign up and encourage your friends to sign up. It's a wonderful board that the online platform that we are putting a lot of effort into, and of course, your feedback is always welcome. If you happen to run into problems, then you can ask for help right on the platform where it says feedback.
So we have
Um,
some more questions.
sure.
So let's take up few questions. Uh,
Hmm. In the
the first
meantime,
question is very basic. Yeah.
mhm.
Yeah. Please continue, sir. You were saying
Yeah, so
something.
in the meantime, if you guys have downloaded the book, Dr. Pius must have given you the link to download this book. Please go
Yeah.
ahead, download the book, read it with me and after me. And if you like the book, do leave the ratings and reviews on Amazon website. Thank you. So, Dr. Pius, what was the question?
So the question is very basic. It is asking what is the difference between ML and embedded devices.
Right. So ML is machine learning. It's essentially a technology which is associated with algorithms, frameworks, compilers, devices. ML can be on your GPU, TPU, on any kind of hardware. Now, embedded means it's a very small device. Like there is no, there are few operating systems, but generally there is a specific board which is not generic. Like your computer, your cell phone, GPUs, and high-end servers, they are generic. Like you can write any kind of program, and you have connected to keyboard, you have hard disk, you're connected to internet, you have things like a cam, a microphone, and such. So all these things are given to you, and also given as a generic processor. What that means is you have the ISA, the assembly language on that processor helps you create any kind of application ranging from finance to networking and such with ease. Uh, and so those are general purpose processors and systems. Embedded systems are very specific. Like you have, instead of the data coming from the internet or being read from the hard disk, you are reading it from camera, directly from the camera or from your audio microphone or movement sensor, your GPS locator, and there are 10,000 different sensors in the world today that provide the input, and you take that input in the application, process it, and produce some kind of signal and create the application. So it's a very limited, very specific kind of application for embedded systems and embedded software. Two different
Okay.
things. Yeah.
Okay. So we have another question, sir. And this is a question from a student. How can I have a career in ML being from ECE domain, and how difficult it would be for me to understand the concept?
Yeah. So, what is the background again? From
She's from electronics and communication background. Jaya is her name.
yeah. So Jaya, like I said in the beginning, machine learning is a large area. You require different skill sets. So for TinyML, I can tell you need five different skill sets. One is your hardware engineer who understands what is the kind of CPU we need, what kind of sensors do we connect and stuff. So, and then you need a software engineer who can take the library generated and create the application right on top. And then you need a data scientist which takes the data and creates the model, right? And then you need an IoT engineer, meaning you have to have this device and connect it in a fashion. Then there are swarm and network of these devices or a group of these devices actively working together, right? And lastly, you have embedded engineer, which understands some of these embedded protocols, like how do you communicate with USB? There is no screen; you don't see a screen connected to this, right? So the way it communicates is a micro USB here, and you connect that to one of the other systems which can take this data and connect it to the screen so that you can debug. There are hardware debuggers. So that's where the electrical or electronics background comes into play, as to when you understand some of these protocols that a data scientist would have difficulty understanding, that a hardware engineer would have difficulty understanding, and these 4 or 5 skill sets come together to create one application. So um, you would have a wonderful career if you start from any one of those domains, and pick up and grow, and accumulate your information and skill sets in these other domains, to if you want to grow as a one stop shop kind of an engineer where you know everything. Most of the industry relies on you know uh, engineers and programmers and professionals who are very smart in one specific niche. So you being going deep into some of these protocols and how to collect the information and create the application using some of these protocols will help you grow your career in TinyML or embedded systems for that matter.
Okay, so we have one more.
Mhm.
Is TinyML a new hardware platform, a software tool, or a completely new AI methodology?
It's a combination of things. Like you have, for example, you have telescopes, right? So there are different kind of telescopes. The one that are for domestic use to the one that is deployed into the space. Very different science, very different optics, right? Um, and it is somewhat similar to that. TinyML is kind of combination of things where you have algorithms, technology, framework, the hardware designed to bring out these applications, and the applications themselves, and sensors. So there are quite a few things that are coming together, and that are building this tiny ML thing, and then of course your um, embedded systems, right? So tiny ML is a combination of things, but there are parts that create that tiny ML ecosystem. So that's what TinyML is called, just like your embedded systems, right? Or your desktop, right? Desktop has a hardware, it has a PCB, it has your software, an operating system, the drivers, and then you have the monitors and such. So it has number of those things coming together to give you something that you can use just to connect to, let's say, internet, and browse internet for that matter. So number of things coming together to create that application. It's a similar analogy here.
Okay, so now you can continue. We'll take up questions in the end, towards the end of the program.
Great. So I hope you guys have downloaded this book. I encourage you to sort of at least skim through it with me. We have finished chapter 4. We're going to focus on 5, 6, and 8. We're going to skip 7 because 7 is somewhat detailed for data science oriented skill sets. So person detection, and again, you can go onto that platform that I showed you before. Again, go onto the playground, and then you would see something similar. This is Visual Wakeword, and you can, you know, create your application here. This is all no-code applications. We are going to add more as and when the time comes, and you can build your own and add application here. So there is another way that you can sort of give us your ideas onto this platform. This platform is free. By the way, we are not charging anyone for this platform. So this is visual wakeword detection, where you can sort of create this application. For example, you want to create doorbell like Ring or Google Nest, and it opens the door when it sees you with facial recognition. In this case, we're going to talk about person detection, meaning it looks at the frame and sees if there is a person. And then, for example, it alerts you, right? I have a door which is a Ring doorbell at my home, and whenever Amazon is delivering, it actually tells me there is somebody on the door, and I see it on my phone, on my TV, on my other screens that are throughout my house. You can ask your smart speaker to stream um, the video that is captured by the doorbell, right? So how does the doorbell know if there is a person, right? That's the algorithm. The algorithm that we're going to talk about is essentially what it uses. A variation of that is used to detect a person. And why it is important, especially for the doorbells that are not connected with electricity, the battery is very important, and you want your hardware to sleep most of the time. Meaning sleep as in like it's not using any of your battery. Otherwise, battery runs out in few hours to few days. For example, your cell phone needs to be recharged every 8 to 24 hours. You don't want other appliances to be charged like that, and that goes for the usability, right? So I'm not going to take you on that platform. I urge you to go on, sign up. But this is how it works. You record yourself for about 2 minutes, and with you in the frame, and then the other data set without you in the frame. When you have these two frames that you hit train, it creates the model. The next screen will show you, and you can capture yourself to identify if there is a person in the frame or not, and then download the application the way we did for our audio use case, right? That's the vision use case that we're talking about. And before we move on to the fourth application, let me give you a fun fact. If it was a live audience, it would be fun to have the quiz. But the fun fact here is the number of sensors today in the world is about 1 trillion, and it is expected to grow by 2032. There is a research study that's done that by in the next 10 years it will be about 50 trillion. So it's going to grow from now to the next decade at a phenomenal rate to give you over 50 times growth on the number of sensors that you will see in the world today. And 10 years from now, when you have those many sensors, there would be flood of these TinyML applications in the next 10 years. So if you're in the first year, second year, or third year, you might want to start learning about some of these. And some of you who are planning to do your PhD, it takes about 10 years from your first year BTech by the time you're done doing your PhD. So the field would be right about ripe, and there would be practically every company that would be looking for skill sets like embedded engineer, your data scientists, and some of these sensors engineers and such. So do pay attention. So this is the last use case, predictive maintenance. Why this is useful is, let's say you have a motor. Now we are used to of seeing motors in our household. It's not economically very useful to know whether your hair dryer is going to stop working, next day or next month or next week, because you can always groom yourself without that. It's not a critical application as such. It has a motor, and there are a lot of other appliances that have motor. For example, a refrigerator, which is one of the critical household appliances. If your refrigerator sort of stops working, then your food will go waste and will start to go bad, and you can't eat that food. And you would need a new refrigerator in a few days. So it's kind of that criticality. And let me give you an example of that criticality in the industry. So there are these very, very large machines. For example, take an example of our customer, which is producing fabric in southern India, and they have over 50 acres of the factory, and there are very large pumps and motors on that factory. And to give you the economic loss, if they lose one motor or one pump for 5 days, they are losing 3 million Indian rupees every day. So why that is important to bring here? Because you want to know if your motor is going to stop working 3 days from now, or would have some difficulty 5 days from now. So that prediction is very important for those companies to continue running and producing the goods and services that they are supposed to produce. So if you can give them a solution that tells them that, hey, your machine is going to go bad 7 days from now, because I know the harmonics of this machine, the vibration pattern of this machine does not look right. It's not healthy. What the person, the floor manager or the engineer can do is to call the manufacturer of that motor or pump and say, hey, something is wrong. Why don't you send your technician? Technician comes in 3 days and says, okay, yeah, this is bad. I'm going to change this component and it's going to be good. So, in doing that, they save millions and millions of dollars in their business, and that's why it's critical. And now, how many industries are there? The answer to that is how many motors and pumps are there. This planet is flooded with motors and pumps. In practically every industry, there won't be any single industry that does not have motors and pumps. So with that, let's watch this quick 2-minute video, and then we'll continue talking about it.
Condition monitoring increases production capacity, motors lifespan, and businesses top line. Monitor your money-making assets like motors, pumps, molding machines, and so on by predicting faults like unbalance, misalignment, bearing issues, and so on before they happen. Traditionally, predictive maintenance solution relies on Wi-Fi, cloud, internet, remote servers, and electricity. Our solution requires none of these. The solution consists of a sensor board and a mobile tablet. Sensor board is attached to the motor. Sensor data from the motor is captured on mobile tablet using BLE or USB. With touch buttons, capture data is compiled into an AI model customized for the motor. The AI application is downloaded onto sensor board. Sensor board is then left running on batteries connected to motor for up to a year. Entire end-to-end solution is trained and deployed in austere environments with no electricity, no cloud, no internet, and in the stealth mode with absolute privacy and security.
So we're going to move on from this. Essentially, the idea is that there are these applications that are very critical, very useful, and require deep skills. And if you can come join a company like our size or somebody else to help develop these applications and make them so easy that anybody can join the platform, create some of these applications, then you would help the world create some of these beautiful, wonderful applications that will help the humanity in the world, right? And the other two applications on this screen is robot assisted surgery. There's a lot of research going on, and these robots can have a precision up to less than a 1 micrometer, which a human hand cannot. And especially when you're doing surgery in the parts of the human anatomy, like human brain, it's very important to have that kind of stability. And so healthcare field and things like headband to detect seizures, and there are number of applications that would make you feel useful, it'll enable you to make the world a better place with TinyML. And there are only two reasons. One is it's very inexpensive. You can create an application and showcase it around under $50. And if it's scalable enough, you can go to a venture capitalist or somebody who has money to start a company and see, if you can create the entire technology by building a TinyML application on top of that. So how does the development work? I have gone through this. These are the 7 steps, 8 steps that require 5 different engineering skill sets, and we have automated 7 out of those 8. Like I said, please do go spread the tinyml.studio or Canvas platform that we have. We are offering for free, specifically for researchers and students, and explore some of these applications that make you feel good. That you might find an interest in building a company on top of these applications. And this is some of the features. And like I said, this technology, TinyML technology, is enabling disruption in thousands of verticals. And if you have time and interest in one of these, please come talk to us, and I'll give you more data as to where and how. And so it's actually, this slide is one of the answers, one of the answers to one of the questions that I think I forget the name. Somebody asked as to what is TinyML. TinyML is a library, a compiler, a framework, and platform. It's part of that, and we provide these 4 things. We are a software company and a firmware company, and there is a hardware component that we partner with other companies. We create end-to-end solutions that are being used in NASA. We're working with NASA. There was a wonderful paper that came out last year. We are also working with U.S. Department of Defense and some of the large, commercial vendors to provide beautiful, wonderful applications that would come on, that would make the basis of the future. And it is like TF Lite Micro from Google. If you happen to know Google TensorFlow, there is a version of Google TensorFlow that is created for these devices called TF Lite Micro for microcontrollers. We are better than Google's TensorFlow Lite Micro. We have a similar software compiler called DeepSeek. And for some reason, my slides have stopped moving. There we go. Yeah, so this is some of the CPU time and peak RAM comparison. Our platform, the features, and here are the resources. With that, I would like to thank everybody who has listened without sleeping, and please do download the book, and if you like it, go on to the Amazon, provide some review for the community to spread the joy around. Thank you.
Okay, thank you so much, sir, for your valuable insights on the field of embedded ML. So I would now request all the participants to post their queries so we can quickly start off the question and answer session. And I would like to invite back our guests. Okay, so ma'am, both the people are here. So let's take up few questions. Like I have one more question from the audience. And this question says, what are the different algorithm techniques in machine learning? So this question is from Mayank. So Mayank,
Um,
let's.
Good question, Mayank. So you're talking about algorithms and techniques. These are 2 different things, but I'll answer that as what are the different algorithms in machine learning. So machine learning is a broader field. Deep learning is part of it. Machine learning has some of the basic algorithms like gradient boosting and decision trees and such, which help you detect the pattern in the data set. And essentially it's built around 2 classes of algorithms, uh, supervised algorithms and unsupervised algorithms. And these are 2 broad classes where you have multiple algorithms for different applications and fields to give you better accuracy and better performance specific to a certain vertical and in the industry. And deep learning is essentially has both of these, where you can have, if your data set is labeled, it's supervised. If your data set is not labeled, then it's unsupervised. There are a lot of unsupervised algorithms that you would use for um, uh, labeled data set. Anything else, Professor Vashist or Dr. Charu, you can add to the answer?
Nee, it was perfectly well answered by you, sir. Actually, the point is that because these students are from this domain, so it will take some time to go through the content of the book that you have already shared and then come back with actual details what we are looking for. Point is that. So till the time they're just coming up with their basic queries, what they have related to this field.
So, moving ahead, sir, we don't have any other questions right now, but we request all the participants to post their questions in the YouTube link, the chat box that we'll be having there. And later on, it can be answered by you. We'll also share your email ID, and also the Canvas platform that is free of cost, and you can enjoy making embedded ML softwares and applications there. So you can all the participants are requested to join Canvas and try out some applications there. So, towards the end of the program, it's been a delightful day, sir, starting off with you in the session. I would like to extend a vote of thanks to the department and the Department of Electronics, the Dean of Engineering, Shruti Vashist ma'am, and HOD Professor Charu. And it was a privilege having you all together on this platform. And since it was a very first presentation or webinar on this YouTube channel, so it was indeed a great pleasure having you with us. So it was a very nice and informative session, and I hopefully see us in future that we'll have some more collaborated videos and webinars and projects definitely. And anything from your side, sir?
Yeah, sure. Like I said, we are happy to help. We have our engineers. Generally, we can assign some of them to answer some of the questions, or even I can come on board if you have enough questions. We're working even in India. We're working with ISRO. We're working with IIT Ropar. I am from IIT Delhi, so working with IIT Delhi as well. Um, and ideas is the only limit in TinyML, given the economy, which is few dollars to purchase a board and get started. Students with the curious mind essentially is a target. This industry is waiting to scale itself with those curious minds. So please do apply yourself. Look at the book, look at other material. And it's not just our company. There are other companies who are also working in the same domain. Do go look at it, and you will find yourself amazed on a daily basis. It's been 3 years. Every day I wake up with renewed enthusiasm for what I'm going to find today, and I've never been disappointed.
Just to add to it, I think we should have continued sessions from sir's side on right from say basic concepts of ML plus embedded and ML what sir was going through, and have a value added sorry this value added sessions on these. It will be very beneficial for all of us.
Yes, ma'am.
One thing I would like to add.
Yeah, yeah, sure.
So, sir has shown, very useful applications at the end related to medical and healthcare. So, we all know we have a strong pillar, Professor I.K. Bhattji, as our Vice Chancellor, who has been actually continuously motivating us to build up products and, innovate in the field of healthcare, especially low cost products, which India people can easily afford. So I think the applications that you shown at the last would be, are very much motivating and will give our students much more innovative ideas to come forward and develop in that area. Thank you so much, Rohit sir. Thank you. It was nice having you. Very useful information. I think many of us have not even heard of TinyML, and it was really, really great. and we'll interact further and take help from you in innovating and doing some research work.
Will be my pleasure. Thank you so much.
Thank you so much, sir. So I would request now all the participants to fill the feedback form. The link is provided in the YouTube chat itself, and later on, by maybe today evening or maybe tomorrow, we will release all the certificates to all the registered participants. And those who have still not downloaded the book, it is available free of cost till maybe another 24 hours. So if you can download it, it is a very good time to download, and hopefully to see you back soon again with some other webinar series. Okay, sir.
Absolutely, and allow me to emphasize one more time. Please go download the book and leave reviews and ratings for the community to
Yeah, reviews are very important.
very important. Thank
Yeah.
you so much. Thank you, everyone.
Thank you so much,
Thank
sir.
you.
So
Thank
we
you
end the
all. Thank
broadcast here. Okay.
Thank
Bye bye,
you.
sir. Bye.
Bye.